And we're back for more work with parallel and perpendicular lines. All right, so what we're going to do today is really kind of combine the first three lessons, all right, together, all right, in the fact that we're going to use writing equations of lines, and we're going to use what we know about parallel and perpendicular lines, all right, to write equations of parallel and perpendicular lines. So you can see that we're going to use all of our standards so far, all right. I can determine if two lines are parallel, all right, and perpendicular in a graphical context and an analytical context. We're also going to then weave in that first standard about writing equations of lines as well. All right, so just to get you going here, all right, I'm going to see if you guys can do problems 1 and 2 here in our opener. All right, so I'm going to let you pause the video, do problems 1 and 2, and then flip it back on, and we'll see how you do. All right, so once again, this is a review. We want to know if they are parallel, right? So lines 1 and 2, or excuse me, lines 1 goes through these 2 points. So I'm going to quickly make, and I'll just do this right here, an XY table. So 5, 4, negative 2, 10. All right, 4 to 6, we go up 6. All right, 5 to 2, we go down 7. All right, so we can see that our slope is negative 6 over 7. All right, and we can see that the slope of line 2 is negative 6 over 7. All right, so now what we want to do is know if they're parallel. So what we have to do is confirm that they have 2 different y-intercepts, because we have to make sure we're not on the same line. So if I write the equation of this line, I'd have y equals negative 6 over 7. I'm going to use that first point there, x minus 5 plus 4. And then I'm going to distribute here. So negative 6 over 7x plus 30 over 7 plus 4. And then if I combine like terms, I get 58 over 7 there. You might have a decimal equivalent of 8 point something. All right, now let's distribute over here. So negative 6 over 7x plus 42 sevenths plus 3. All right, and then if I look at that, that's going to be 21, so that's going to be plus 63 over 7ths. All right, so we see the y-intercept here is 63 sevenths, which is, I think, 9. All right, and we can see that this is 58 sevenths. So we can see that they have the same slope, but different y-intercepts. So these would, in fact, be, all right, parallel. All right, and there's a symbol for parallel if we haven't introduced that so far. All right, now let's look at number 2. All right, we want to know if these are, in fact, all right, perpendicular to each other. All right, so now when I look at this line, I have to do a little bit of work, correct? All right, to find that slope. So I'm going to subtract 4x from both sides. So 5y equals negative 4x plus 20. I'm going to divide by 5. And I get to my line as negative 4/5 x plus 4. So I can see that my slope for our first line here is negative 4/5. So now I need to come over here, and our graph is a little fuzzy, but it looks like we definitely have a point here. And it looks like maybe there's a corner point here. All right, so if I find the slope of this line, I go up 1, 2, 3, 4, and then over 1, 2, 3, 4, 5. So I can see that the slope for my line that's graphed is 4 over 5. So once again, they're opposite but not reciprocals. And remember, to be perpendicular, both things have to be true. So these would not be perpendicular. Okay, all right, so hopefully we have kind of got the idea of parallel and perpendicular in mind. So parallel lines have to have the same slope, different y-intercepts. Perpendicular lines have to have opposite and reciprocal slopes. All right, so if we think just real quick down here about our notes, right? Okay, so we know our point slope form, we know how to find slope, and we know that parallel lines have the same slope, all right, or equal slopes. The same slopes, right? And we're going to just take all of this information and we're going to use that to write equations of parallel lines. All right, so okay, and I didn't mention this earlier, but we are on page 93. You can see that there. So let's go ahead and flip to page 94, and we're going to go through 3 problems together. All right, so let me just adjust my screen here a little bit. There we go. All right, so now, when we look at writing equations of lines, all right, that are parallel, we need 2 things, right? So we need a point, all right, and we need to have the exact same slope. All right, so now when I look at problem 2 here, write an equation of a line that is parallel to this line and passes through this point. Well, notice when we write our equation in point slope form, and I'll just write that right here, well, it already tells us the point. So we have to use the point that's given. So right away, I already know this has to be x minus 1 minus 5. So now the only thing that's missing is slope. And if I want this line to be parallel to the given line up here, it has to have the exact same slope. So once again, I have to just go through my process of finding the slope of this line. So if I subtract 6x from both sides, I get to this. And then if I divide both sides by negative 7, I get that my slope would be positive 6/7 x minus 2. All right? And so notice that that would be the slope that I need, because if I want them to be parallel, I have to have the exact same slope. So I just take the slope from this line, and I put it in my new equation. And that's all it is. All right, so let's look at problem 4 here. Let's look at problem 4. So once again, we want to write the equation of a line that passes through these points and goes through this point. Well, I have to use that point, so right away, I know it's going to be x minus 4 minus 2. So I just want my new line to have the same slope as the line that goes through these points right here. So let's just do a quick xy table and find that slope. So this would be negative 3/6, all right, and 1/6. And notice something. We saw this in the prior lesson here. I go up 0. In the y direction, I go up 4. So notice my slope here is 0/4. Or 0 over 4, which is just 0. Now remember, that should tell you that you have a horizontal line. And you can see that our y matches, so this would be really y equals 6. Now notice what happens here. I can take and plug 0 into this right here. And then 0 times everything here would be 0, which would simplify down to y equals negative 2. And once again, we know that to be parallel, I have to have 2 horizontal lines. All right. Okay, so here you go. All right, so let's look at example 5 here. Okay, so when we look here, all right, so now let's look at problem 5 here. All right, so now this is very similar. So we want to, all right, plot a second point and draw a line, all right, with point A that's parallel to this given line. So once again, it all goes back to slope. So let's start by finding slope. So notice I go up 1, 2, 3, 4, and I go over 1, 2, 3, 4, 5. So then what I want to do is just recreate that same slope from point A to get to my second point. So I'm going to go up 1, 2, 3, 4, and then to the right 1, 2, 3, 4, 5. And then we're going to call that point B. And then notice if I draw that line, all right, it would be AB. And the way we name a line is we take the 2 letters and we put a little line over the top of it. So that's line AB. And the equation would simply be our slope, which is 4 over 5. And then I could either use A or B to write the equation. I'm going to use A here, which is negative 5, 3. So x minus negative 5 and then plus 3. All right. So that is how you write the equation of a parallel line. Now, let's flip to, let me look at my paper here, to page 96. All right, and we're going to skip all those examples and just flip to page 96 here. And we're going to do perpendicular lines. And then just as to help you recall this, they have opposite, right? And we've said this already today. And reciprocal slopes. All right, there you go. Okay, and I'm just going to go through a couple of very quick examples, all right, and it's a very similar process. The only difference is how you get the slope. So let's look at 97. Let's look at 97. And I'm just going to go through 16 and 18 because it's really the same process here, right? So notice the only difference is just pay attention to the wording. We want perpendicular this time. Now I'm picking 16 because we've already solved 16, and we saw that when I solved this equation, we got y equals, I'm just looking off my notes there, that, right? So now if I want my line to be perpendicular, I have to have my slope to be opposite and reciprocal. So if my slope here is 6 over 7, my new slope would be negative 7 over 6, and I would just use that same point like we did before.